So I'm Edward from Goldman Sachs, and I'm going to give you a lightning talk about open source software supply chain security. Most of this you would have seen some of the data points discussed by earlier folks who had presented, and a lot of this, there was a presentation from a gentleman from Citi who said he was just going to grace the surface. My presentation is also similar because OSS supply chain security is a huge, vast topic, and I'm just going to give you some high-level things about the topic, right? So let's start with the basic on what exactly constitutes the supply chain. So it's about the different components, libraries, tools, processes used to kind of build, develop, and publish a software artifact, right? So when we talk about a supply chain, we need to include aspects of developers, the actual code, the dependencies from where they come from. With growing AI, definitely the AI models, containers, and the CI/CD pipeline. So all of this needs to be taken into account. So a few data points, again, which you can find over the internet. The 8th annual State of Software Supply Chain report given by Sonotype actually mentions there's a 742% average increase in the software supply chain attacks over the past 3 years, right? So 6 out of 7 vulnerability comes from the transitive dependencies case, right? And about 1.2 billion vulnerable dependencies are being downloaded each month. And 96% of known vulnerable open source software downloads are completely avoidable, depending on the state of the solution which you implement in your own firms, right? A bit more facts. Again, I'll just probably skip through a few of these. 96% of the total code bases contain open source, and 84% of them at least contain one vulnerability, right? And of course, we all remember the log4j vulnerability, which I would like to quote here, which paved way for the remote code execution, right? It got a CVSS score of 10, which is the highest possible ever, right? Which led to devastating effects. I think all of you in your own firms would have run from post to pillar to try to figure out how to insulate ourselves or yourselves from such a incident, right? Now, moving on to the fact, why supply chain attacks, right? Coming to think of it from an attacker's mindset, investing time on a single target versus investing the same time on probably some open source component, right? Which is kind of widely used across the worldwide, right? So the impact is more on the latter, which is affecting the entire ecosystem, and it's easier to attack the brittle supply chain components than enterprise tools, which are usually have more guardrails around them. Plus, in an open source system, which is interconnected, complex ecosystem of tech people, you have multiple attack points which are like vulnerable. And also coming to the nature of attacks, as you are aware, in terms of open source, it's mostly pull, right? Instead of the attacker or someone trying to push malicious components, they just need to break something in the open source supply chain, gain access to that, and then kind of introduce the thing. Now, I'll just skip through this as well. High level, we know what open source is and what are its great strengths, flexibility, agility, and all of that. But one sad fact at this point in time is the truth that many organizations actually lack a view into the open source components they use. They do not have a well-formed inventory of the open source components, which again is paving the way for all of these supply chain attacks at large scale, right? And one other fact to notice, the sad truth, there are many beneficiaries of open source, but then there are only a few who kind of come forward to volunteer and upkeep these open source projects, right? So that's also another thing which we need to be aware of. This is just a compilation of the supply chain threats in the recent past. I think this was taken from the Microsoft's study. Now going to the financial services industry, right? As we all know, we need reliability. There are a lot of things from the regulators that come our way, specifically in my role and the team here. We have been working on a lot of regulatory deliverables, including the DORA. Definitely we tend to use a lot of open source components from CI/CD to databases, which comes in handy and kind of avoids vendor lock-in situations as well, right? So given all these regulations, how do we actually kind of secure ourselves, right? A few high-level things again. I know we're running out of time. But then one major thing is the first thing which I mentioned. You need to have an inventory of the open source components so that in case of any open log4j or any of the issues that might happen, you have a way to check the blast radius of the things, right? The second thing is checking the sources from where we kind of download our open source components. We always need to fetch from an official upstream repository in a secure manner, right? And many times there are people who actually opt into check out pre-release code, which is a big no, right? That is the most favorite place for attackers. Then there are a few other things which mostly we'd be doing, which is like validating the checksums, the digital certificates to verify the integrity and all of that. And I think this was also quoted in one of the earlier presentations, which is the namesake attacks, which is more around the counterfeit components which look alike in their names. And we go and download or use the wrong component, and hence we are subject to the vulnerability, right? Plus one other thing as a general recommendation we need to do is we need to see the recent commit activity. At least in the last 3 months there should be active commit activity, because there have been cases where I've seen a lot of open source components being abandoned years ago and still their use in live production systems as well, right? Yes, inventorize, I think I've covered that. And once we have an inventory and once we are sure from where we are sourcing it from, the next thing is continuous monitoring, which we need to do, which is like scanning the CI/CD pipeline, scanning the components that we are using for updates and updating them and keeping up with the patches, right? And the other thing which would really come in handy as well is, say, we hope for the best in terms of adopting all the best practices, but we need to have a contingency plan also in place. In case, worst case, something happens, how do I kind of come up with a list of steps that I need to remediate that incident from happening? It's kind of an incident response plan, right? How do we, say for example, if that single component which has been impacted by the vulnerability use across 10 systems, how do I kind of shut it down in a minimally invasive way with less, with the most optimal use of resources and so on. Another thing which we could consider doing is also ethical hacking and other bug bounty programs, which kind of incentivize hackers to hack on specific assets for bounty, right? And going to the next one, S-bombs, definitely yes. This is not a new concept to us. So that leaves us with the next part, right, which is moving on to the AI models, which has recently come into play a lot. So AI models also definitely can be tricked to expose sensitive information, right? So things like prompt injections, training data poisoning, DDoS, data leakage, all of this have topped the OWASP list. And actually, if you look at open source LLMs, organizations have started using them because the more vetted ones are expensive. But these open source LLMs are at more risk to the supply chain vulnerability. So again, in terms of maturity of security practices, in terms of AI models, we don't have much. It's still in very nascent stages, right? The code, but a few things which we could do is the code generated by the model should be subject to maybe the software component analysis, similar to how we do the other open source code, right? And also we kind of review the provenance or the source of the model, from where it came from, and how is the model constructed and so on. Some basic checks to make sure we are not falling into the wrong thing. Then definitely CI/CD is also an important aspect in terms of supply chain vulnerability. There are a few notable examples, which is SolarWinds, CodeCough, and all of that. Things like artifact signing, verification, secrets planning, etc., can be kind of used. Moving on to a quick thing about container security. With containerization becoming really a famous or like thing, now the vulnerabilities could also get packaged along with the applications, right? So the recommendation is again using scanning tools and making hardened containers that have minimized the vulnerability footprint critical. Again, it's mostly scanning using SAA tools and remediation of vulnerabilities, which we will kind of do. So that is pretty much it. I know it's very basic, an overview of software supply chain security. Thank you.